So today we're going to do the first 3 examples of 7.3. We'll finish 7.3 tomorrow. Okay, compound events. Compound events. What do you think of when you hear compound events? What comes to mind? 2. Okay, it's going to be 2 or more, right? So no longer is it, what's my probability that I spin a 4, which is only one event. It's, what's the probability that I would spin a 4 on or roll a 4 on a number cube and flip heads. Okay, so of 2 events happening. They might be kind of unrelated to each other, or I might say, on a spinner, what's the probability that I would spin a 4 and then I would spin a 2? Okay, so it's just more than one event. What's the probability of more than one event occurring? So what you need to know is a sample space is the set of all possible outcomes of one or more events. The sample space, for lack of a better word, it creates the space for us to show that. All right, so example 1, finding a sample space and showing it through a tree diagram. So we see a chart over on the right side of the screen, okay? The first thing I want you to do is identify how many categories you have. How many categories do you have? You have the choice of bread and you have the type of meat, okay? So there are 2 categories here. Thank God it's not 3 or 4, and you'll see why in a minute. The more categories there are, tree diagrams become very difficult, very intricate. Okay? So what I want you to do to start your tree diagram is I always want you to start it with the category that has the fewest amount of options. Okay? So does bread or type of meat have the fewer options? Bread, okay? So you're going to do bread. You're going to label that column, and you're going to go wheat and sourdough. Okay, so leave some space between the 2 because there are more types that I kind of have to list out. So if I go up to the counter and order wheat, the types of meat that I can put on wheat, all right, I would list next to it in the next column. So I want to just pause for a second, give you guys a minute to catch up. So now if I choose wheat, my types of meat are ham, turkey, steak, and chicken. I can go wheat ham, wheat turkey, wheat steak, wheat chicken. All right, I can choose each one of those. So guess what my options are for sourdough? No, still the same options. I can go sourdough bread with ham, sourdough bread with turkey, steak, and chicken. So for each type of bread, I have the same options of the meat. You see what I'm doing is I'm creating combinations of choices. All right, give you a minute to catch up. Now what we're going to do is we're going to list the outcomes. And really, this is the whole point. And I'm going to do a little bit of abbreviating just because it's quite a bit of writing. My first outcome is that I can pick a wheat ham sandwich. My second outcome is that I can pick wheat turkey. So what tree diagrams do is they show us specifically these are our outcomes. These are our options. Wheat ham, turkey, wheat steak, wheat chicken, and then sourdough, I'm going to abbreviate SD for sourdough. Sourdough ham, turkey, steak, and chicken again. All right? And again, the tree diagram versus the method that I'm about to teach you, the difference is with the tree diagram, you can actually see your options. All right? It's not like you walk up to the register, and in a minute we're going to talk about how many different options you have, and they say, well, this is your number of options. And you're like, okay, well, what does that mean? Well, a tree diagram shows you specifically what those options are. So how many outcomes do I have? How many outcomes do I have? I have 8 outcomes. So I can calculate that. Now that I have all my outcomes listed, I can see that there are 8 possible outcomes, okay, or 8 possible options or combinations. I guess I could say 8 sandwich combinations. All right, so let's abbreviate that. 8 sandwich options. We do want to say what it is. 8 sandwich options. Okay? So now your book throws in this one other, you could say just this one more twist. Your book says now the restaurant decides that they want to add a third option for bread. They want to add a multi-grain bread option to the menu. How many different options now are there, Hannah? There's 12 options, because if I add another bread option, there's still how many meat combinations? 4. So that would just add 4 more to make 12. Does that make sense? Yeah. And I could keep doing that. All right. So just to give, I guess their customers some more choices. All right. So the first way that I can calculate possible outcomes is through a tree diagram. However, tree diagrams are not practical when my categories grow to be really large numbers. Like if I have 5 options in a category, can you imagine doing a tree diagram? It would be a lot of work. So there's another method, and this is definitely the more common one, or I guess I could say commonly used method, and it's something called the fundamental counting principle. Okay? And it says take each category and multiply the possible outcomes in each category to calculate the potential outcomes. All right, so here we have a table, and I have partially filled it in. Okay, and I did that on purpose. All right, this shows all of the possible combinations. And, I don't love that I'm kind of teaching you one method, but I'm kind of showing you the breakdown. It's a little confusing with the tree diagram, but we'll go with it for now. So we see what 2 things happening. Find the total number of outcomes of rolling a number cube, option 1, and flipping a coin, category number 2. Okay? So how many categories do I have? I have 2. The first one is rolling a number cube. All right? So I've got these values. I could roll a 1 and flip a heads. That's one combination. I could roll a 2 and flip a heads. Roll a 4 and flip a heads. All right, so we're just filling in the rest of the table. All right, I could go 2 tails, 3 tails, 4 tails, 5 tails, and then I could go 6 heads and 6 tails. All right, basically the chart is showing you the possible combinations. The part that is kind of interesting why they put this in there is we're kind of supposed to bypass that. All right. And our fundamental counting principle says, okay, you have one category that's a coin. How many outcomes are possible when you flip a coin? How many outcomes? You have heads and tails, right? So for the coin, there are 2 possible outcomes. Okay? For the coin, there are 2 possible outcomes. And for the number cube, how many possible outcomes are there according to this chart for the number cube? There are 6. I can roll a 1 through a 6, so there are 6 possible outcomes. And the fundamental counting principle says I can actually bypass having to list all the outcomes. I can just say if there's 2 outcomes for a coin and there's 6 outcomes for a number cube, I can multiply them together. 2 times 6 is 12 outcomes. I can just multiply them together. And we're going to reinforce this in the next example. I think it'll kind of make a little more sense. But what I do is I take the total number of possibilities. There's only 2 possibilities for a coin, 6 for a number cube, and I multiply those numbers together. All right? No tree diagram. Don't have to list, every combination. I just calculate it with the fundamental counting principle. All right? So let's look at another one. Okay? These are 2 separate questions. All right? The first one, you're using the picture, the wardrobe, the picture of the wardrobe. This has nothing to do with the second question yet. Okay? So look at this picture of the wardrobe. And it says, how many different outfits can you make from the wardrobe in the closet? So I look at this picture, okay? I'm basing it just on the picture. And the picture is in your notes. Hopefully it's kind of clear. I know it's black and white. Okay? I have, what do you think is folded up here on the top shelf?
Jeans.
Pants, jeans, okay. Hanging up? Shirts. And on the ground? Shoes. So how many categories is that?
3.
That's 3 categories. So now I'm just going to count how many how many options are there for each category? How many pairs of pants do you see? 4. So I'm going to write 4. That's the total number of possibilities for that category. All right. How many shirts do I see?
7.
Yeah, 7. I know they kind of blend together. All right, 7. And how many pairs of shoes do I see? 3. So I take those 3 numbers, and my fundamental counting principle says if I multiply the number of possibilities for each category together, it will give me the number of combinations. So what I would do is I would multiply the easier numbers together, like 4 times 3 is 12, and then 12 times 7 is 84. You could say 4 times 7 is 28, and then 28 times 3 is 84. Community of Property says you can multiply in any order. Okay, so anyway, once you multiply them, you get 84 outfits or outfit options. All right, so has anybody ever said, oh, I don't have anything to wear? And your parents are like, your closet's full of clothes. Okay, so look at how many outfits are actually possible with only 4 pairs of pants and 7 shirts. All right, so, you know, not everything necessarily matches, but, all right. Okay, so now the second question. Now you have different numbers in your categories. I want you to calculate, work in your groups, and figure out how many options you have for outfits. Right, so how many different outfits can you make? All right, so we go 4 times 5 times 5. And what'd you guys get? 100 outfits. So I had a question earlier, and I thought it was a great question. They said, well, what if I said 100 outcomes? Technically, that is a label, but it doesn't say specifically what it is. I would prefer outfit options or outfit combinations or even just outfits over outcomes. I don't know if I would really take off on a quiz or a test, but you do want to try to label it according to the, you know, what the problem is talking about. All right, so we are going to take a time out and kind of stop here for today and do some classwork together. There are 2 examples left that we'll cover tomorrow in part 2. All right, so that'll be everything for part 1 of 7.3.